Okay, so when you open the Vissim, Vissim is consists of, and this is the software Vissim. It's like other normal Windows application. So you have the menu, you have the toolbar. On the left side, uh, the network objects. So whenever you want to put links, these are displayed like anything in the traffic. So stop signs, signal heads, detectors, vehicle input. So all of your toolbox is normally located here. On the right side, you have your network editor. So in the network editor, normally it shows the map of the world. So I want to create a network here. Thank you. So I want to draw a network in Waterloo. I will try to zoom and find. Am I right? Okay. So here, I think now we have. Is it Waterloo? Cambridge. Let's go to somewhere that I'm familiar with. Is it Waterloo again? Yes, I think that's Waterloo. Okay. So here, as you can see, now I zoomed into the Waterloo. It's usually used the Bing map. So here in the layout option, so you can see here there's a layout. So sorry, let me change my mouse setting. Pointer. Okay, so that's good. So now here, for example, this is the University Avenue here, and this is the King Avenue in Waterloo. I can go and switch and change my options so I can show the map. So here it's using the default map service, which is normally Bing, and I can go to OpenStreets. I will agree to the terms of the OpenStreets. As you can see, it will show me the map of the street as well. Normally, I prefer it's a personal preference. I will normally prefer uh, the Bing because I can zoom in and I can see the lanes and I can design the network very well. So just first of all, I want to model a very simple link and I put vehicle inputs there and I want to simulate some vehicles there. So basically, I will go and select the link from the tools menu. I will push down the click and control and I will draw the link from, for example, here to here. As you can see, when I draw it, it will show me the link property. It will ask me for the number of the link, the number associated with the links, number of lanes. Suppose that I will put two lanes. It's normally one direction, and I can name it. For example, I will name it University and University Avenue. For example, it's a westbound, almost westbound. So it will ask me, okay, what's the type of the behavior of the network? So I can put it as a urban or freeway. So here is a urban motorized vehicle. It asks me for the type of the display type of the network, and here it's showing me, okay, what's the lane numbers here? So I said it's the two lane. What's the width of that lane? Is it so I can block some of the vehicles to that network. For example, I want to simulate a network that has a dedicated bus route. So I will go and eliminate all of the cars except the buses here. Or I can do block all of the network vehicles, or I can say that there is no lane changes. So I will click say OK. And so as you can see, it will draw me the link here. So it's showing me the link. So I can, if I press Control A, it will show me the the one line representation of the network, or it can show me the actual lanes here. As you can see now, I have my network here. I am one of my streets here. And if I want to make some curves and I want to, for example, fit my in my lane to these streets, so I can right click on the network and I can say add points. So it will add a breakpoint and I can move the network around that points. As you can see, I can just drag and drop and sorry, I can pick these points and I can change the shape of the network. I can add as much as I want, so I can go and add multiple links, multiple points. I should look at my monitor instead of that one. So I can add points here. I can go and change it here like this one. And if I want to, and this is how we draw the links on the network. Before going forward, I want to show you something. Anything that you want to learn about the Vissim is located normally in the Vissim folder. Let me go. There is a one important folder here which is called docs. And if I go to the in English one, you can see there is a Vissim manual here. It's a very detailed manual. Whenever you want to go and read this manual here. As you can see, I think it's 900 pages. So for each detail that you want, there is plenty of detail for you to go and read it. So in this session, I will try to make you understand the whole interface and what's going on about the system and the Vissim, and then you can go for details. If you need to, for example, do add modify the links, you can go there and read more about that one. So here in this session, I'm trying to give you a general explanation about how the Vissim works. And this is a very good manual here. There are some other manuals here, like the COM manual or installation manual. You can use those ones as well. Beside that one, um, there is, okay, in my installation, I think I do not have. There is an example folder as well. I will show it to you later. But basically, this is how we use the Vissim. Now I have my network here. I have my link here. I want to put some vehicles and I want to see how that one works. So here, as you can see, there is a vehicle input here. I will go here to this link and I will right click here and I say that, okay, add the vehicle input to this link. And as you can see, there is a black line is added to this point here. As I double click on that one, it will show me the list of the vehicle inputs here. So this one is the vehicle input one. I can change the name. I can say that, for example, university is westbound vehicle input. And I can say that, okay, what's the volume that I want to put there? So I want, for example, what's the saturation rate, flow rate here? What do you have any idea about the saturation flow rate on a normal street, a two-lane street, one-lane street? No, it's around normally 2,000 vehicles per hour. And so here per lane. So here I will just, for simplicity, I will put, for example, around 1,500. It's very undersaturated because it's a two lane. And I can choose the vehicle composition. So I can define different vehicle composition. What does the vehicle composition means is that, for example, I have buses, I have trucks and other vehicles. And those vehicles have different variables. They have different acceleration, different network properties. So I will use the default for now, and then I can press play. It asks me for saving my network. I will go to the desktop, and I will say that, okay, we'll see, sample, and I will call it link. Okay, so as you can see, it will move the cars in the network, and the vehicles will go through the network. I can go to the 3D model of this one. If I click here, you can see it can do the 3D modeling. And I can go for, it doesn't have the 3D right now, just let's do it later. But as you can see, it's simulating my network. And here on the downside, as you can see, is my simulation seconds and number of total vehicles in the network and some other measure of performance here. So here is very simple example on how you can do simulating very simple link, just putting some values there. And for example, if you want to, so you have already, I think, covered the link flow relationship. So for example, green shield or Van Aert model, you already covered. So you can simply just model this link here, and then you can extract the volume, you can extract the density and other information, and you can draw the information for the charts that you want to draw in fields or other network types. So now let's go to a more sophisticated problem. So I want to do a simulation on how we can model an intersection in the urban area. So first of all, what do you think? What are the components that we need to model?
Is it signalized or unsignalized?
Yes, let's do it a signalized one because it's more complicated. It has more detail. Let's do a signalized intersection. So what should we model here? What do you think?
First, we need to define the intersection itself, like the layout of the
Exactly.
intersection. Right?
So the geometry,
Yes.
we want to see the geometry. So I will write down layout is better. We want to see the layout of our intersection. So how many lanes are coming? So what are the turning movements, for example? What are the turning movements in the next? So which movements are allowed in the network? So what else?
The light signal durations, like the phase and cycle durations of the.
Yes. So the signals. So basically, we want to see that where we have signal heads, what's the phases? What is the timing of the? What is the timing of the signal? What else we need? So now we have the layout, lanes, turning movements. We have the signal heads, phases, timings. What else? Demand, the volume.
Yes, the arrival and departure rates.
Yes. The departure rates, we do not have any control on that one because we are doing the simulation. It will happen. So the simulation has some theory behind, so it has following the other theories there, and it will follow that information. But we can model the vehicle inputs, so the demands. So normally we use it as a vehicle inputs, as we did it in this network. So here, let's go to the intersection here. I will delete this link. Let's start fresh. So here's, I think, University and King. Very typical intersection. Normally, as you can see, two lanes are coming, each in each direction. Normally, there is a dedicated left turn here. There are two lanes moving here, the same here. So normally we have here. And I suppose that for the simplicity of our network, I will assume that we will have these two signal phases. So one for the northbound, eastbound, and one for the eastbound, westbound in the university. Just if we do that one, we can do the other things. We have some some kind of curve around the intersection here. And sometimes it's very good idea to go and walk in the intersection if you want to model it. If you don't have access to that one, use the Google Street View, and you can move there and you can have an idea how the intersection looks like. So we will try to model this intersection. Do we need any other information? Do you think?
The type of vehicle, is that like a heavy vehicle or passenger car?
So Normally the vehicle composition is in demand. I will just put it here. The vehicle inputs, normally we want to do the volumes. And we want to know the vehicle composition. What else? Sorry, what?
IO matrix. Origin destination demand.
Yes. So okay. So that's a good question. So how do we do inputs in the network? That's a good question. So normally there are two types of vehicle inputs. So if you want to model the demand, there are two ways to do it. One is to have the OD matrix, so origin destination matrix. Okay. So origin destination matrix. And the second one is that vehicle inputs or routine normally. So how the vehicle inputs normally is a very simple form. We know the turning ratios. Okay. So how do the origin destination works? So you cannot see there. Sorry. OD matrix. I will try to write it there. So normally the OD matrix, normally if there's a study in your area and say that, okay, so for example, we want to model the University Avenue. So here's the look of the University Avenue. Here is the river. Here is King. And here is Hazel. And Philip here. Philip system. And here is the university. So normally what we have here is that normally what people have, normally they will define some origin and destination. So for example here, I will define an origin here. For example, I will define a point here 1, 2, 3, 4, 6, 7, and 8 here. So then we will have a matrix which will write down the origin destination here. 1, 2, 3, 4 to 8 here, and the same here. I will go to 8. Let's mark up 7. So here it should be 0. So between 1 and 1 there is no vehicle. So between 1 and 2, for example, there are 200 vehicle per hour demand. So 200 of the vehicles going from 1 to 2. Or, for example, from 1 to 7, there are 800 vehicles going that way, for example, or something like that. This information, if this information is available, you can put this information into your simulation, and you can define your OD matrix, or you can define a dynamic assignment here. But normally, in normal traffic studies, this information is very expensive. Normally, it's not available, and it's very hard to obtain. Normally, what people have is that the turning ratios. So normally, they put some counters, or they have loop detectors. They have the count of the vehicles here, normally. And so, for example, they know that from this direction, there are 2,000 vehicles per hour is the flow. They don't know any demand, any information about demand. They know only the flow of the traffic. And they put some people stay here and do some observation. And they see that, okay, there's a 10% turn ratio to the right. So you have a right movement, here 10%. You have 75% through movement, and you have 15. So you will have 15% left turns. You will have the same information for all of the approaches to your network area. Normally, this information is very easy to obtain. So normally, traffic studies. So sometimes there are loop detectors installed in this area, and you have the volumes, the count of the volumes which pass. The region normally have this information. Sometimes they are not connected. So they will send some traffic engineers there, and they will collect information. So basically, they will stay there. They have some devices. They put it's there. And say when the vehicles are passing, it will count the vehicles, and so on. They will extract this information here. So normally they have a standard sheet for each intersection, and they will have the information. And normally they use this information for traffic signal and offline optimization normally. So we will assume that we will have, so for the simplicity, we will assume that we have this information. So you can do this one later on with Vissim or other traffic signals. They are traffic simulation networks. So I will assume that in our network, which is just this part of the network, so here, for example, I will assume that, so because we are doing this section of the intersection, let's assume that I do not have, I want to only model this part, and then if I have this intersection, I can copy and do other there. So from this direction, I will have 2,000 vehicle per hour coming. We will play with this value to see the effect of this one. And I will have the same example, 10% right turn, and I will have 15% left turn, and I will have 75% road movement. And for the other direction here, I will assume that I will have maybe 2,500 vehicle per hour. I will have maybe 20% right turn, and then I will have maybe 10% right turn. Is that fine? Does it look like fine to you? I think these values are reasonable. I mean, normally this is true. So then we will model this too and see how that one works. Okay. So first of all, I need to draw the links to my network, to my intersection. Where's my mouse? Okay. Okay. So here, this is my network. I will try to model around 150 meters here. I will model this intersection here up to here to here, and I will model this one to here. I want to show you how you can draw a link with this curve here. So let's do this network here. So I will go and choose the links. I will press Control, and I will draw it from here. Sorry, what happened? Okay, I will draw it from here to here. It has two lanes. I will name it as Uni westbound, okay? And everything looks fine. It's urban, road gray, and that's fine. So now I have this link here. So I need a two lane here. Sorry, I need one left turn lane here. So it's one lane, and I would say that uni in left turn. That's fine. So it's not very good aligned. I will put it here. Then, so the traffic which is coming from this direction, they need to come. Some of the vehicles here will do movement to here. So I need to connect this one to here. So there are generally two types of simulation. So normally one type of simulation, they have links and knots. So you will define a knot and connect the links there, like the Einstein is doing that one. So you will connect links to that knot, and it will do the intersection for you. There's one other type of simulation which is the Vissim is that type, is that you will draw the links and you will draw all of the turning movements and all of the interactions in the intersection with the link, which is they call it connectors. So these two type of networks is there. So here, if I want to connect this one to here, suppose that I want to connect it from here to here. I will draw, it's similar to drawing a link, but I will start my right click and control on that link, and I will connect it to here. As you can see, it will recognize it, and it will make a connector. As you can see, it says that it's a connector. Normally, the number associated with the ID of the connector is normally it starts with 10,000. I can put a name for that one. Just I would say that okay, uni westbound, sorry, westbound left turn. I will call it, and it's similar to the links. It's airbag motorized. It's a red gray the display type, and the second lane of this one here is connected to that one. If I change it, as you can see, it will change the shape. It will go that way. Normally, the first lane is the first lane from the right side of the link. I can add, so for example, it's a very straight line. I want to add some curve here. So I can add some points here. I would say that, okay, draw this one with 5 points here. And I will say okay, and it will draw the lane for me. As you can see, it made some curves and it added 5 points in middle. So it's make it a little bit nice. I can move them as I want. For example, I want it to be like this. Oh, sorry, I should not have moved that one. And I can add some points even if I'm not happy with that one. I want to add some curves, more curves here, and that's how I draw the connectors. Then I want to draw the link, which is coming from this way to here. So the number of lanes here is 2, and just for now I will not name this one here. And here I have my intersection here. For my other directions, I will do the same. So I will simply draw these ones very quickly. So I will draw 2 lanes here. I will draw 1 lane here, and that's fine. And then I will draw a connector from here to here. So as you can see, there are some parts we didn't talk about here. You can see that, for example, for the route option, so if the vehicle did not have the chance to do the turning movements, it will stop 5 meters before the end of the start of the connector. It will stop until it finds some space there. Or the lane change when the vehicles needs to do the lane change. For example, there is a vehicle in the far end of the first lane. It needs to move to the left lane first and then move to the connector. So this one will define the distance that it requires to do the lane changes here. And so, for example, the desired direction is that, okay, what type of direction can go? Is it the left turn or right turn here?
Sorry. Are those following a distribution of some sort?
Here, no, there's no distribution here.
Meaning that they would just change their lane 200 meters.
Yes. So the behavior is coming from something else, which is the car following model there and lane changes. We will go there because I want to model a very simple intersection, and then we will go and play with some lane changings. And so, for example, we go the car following model parameters and we will adjust them as well.
Is it possible to copy and paste this link?
Yes, sure. So normally what I do, just give you an hint, because if you want to do it, you see this is a 4-lane intersection, which is very common. So you can draw the links here, but normally I do a one intersection, and then I will keep it, and I will copy paste the 2 other ones. Normally the geometry are similar normally. When you do many simulations, you will have some typical connections, intersections, and for example, you have 1 lane, normally 2 lanes, and normally, for example, this geometry is very simple. Just whenever I want to put it here, I will just do some fine tunings and some small adjustments. You had a question?
Real ask is really weird. I don't know how you're getting the links to draw.
So you need to press Control and then Control. So when you install the Vissim, at the first installation, you have 2 options. You can say that, okay, the right click will do the drawing, or you can say that, no, Control right click will do the drawing. It's a little bit tricky. It's not normally what people used to. I prefer the way that AutoCAD works. Normally it's very intuitive and that one, but this one is not that much intuitive, I think, personally. It's very good, but you need to, if you use to AutoCAD or some other softwares, it's not similar to them, and there is a time that you need to spend to get to used to it. And so here, for this one, so here, now let's do the downstream here. I want to let me copy paste this one. I will right click, I will copy this one, and then I will paste it here. So now the direction, unfortunately, is this way, the way that I draw it. So I will right click on that one, and there is a link, reverse the direction. And now the direction is reversed. How can I identify the direction? As you can see, there is a small arrows here. It's showing me the direction of the link here. If you think that you can forget it, you can have some. You can see there are some pavement mark here. As you can see here, I will put some pavement mark here. For example, I will add a pavement mark here, and I will say that it's arrow. It's a left turn. Sorry, it's a left turn. It's not right turn. Okay. So now I have something beautiful here, and I will remember this is my that's movement. So I will add some. It's through and right turn, and this one is I will add pavement marking through movement here. These ones do not change the behavior. It's just for you. It's a pavement mark. It's just a beautiful thing that you will put there for yourself or for your customer, whatever. I mean your supervisor. So here, and if I press Control A, it will go to the. You see, it will go to the lane view. It's just showing me the links. It's just the network here. I would say that okay, I like it this way. So I will draw the connectors from here to this one. Oh, sorry, I don't want pavement here. I will go to the link and I will draw right turn here. So now I want just the first lane to the first lane of this one here. It's a it's a little bit much curve, so I will add maybe 10 points. Normally 10 to 15, I think makes a good point and good value there, and everything seems fine. So now it looks nice. If you do mistake something and make something like a cardiograph, you can just right click and say recalculate the spline and it will reset it for you. Or if you, for example, I will do one more complicated here. I think this is like a snake, and I think this is the best example here for us to do it. And then for the through movement of, okay, I need to draw the lanes here as well. So I will draw some links here. This is the through movement, 2 lanes very quickly. And then I need, let me extend it to somewhere here. Okay. And then let me add something like this here as well. 2 lane as well. If you want to be more accurate, for example, here, maybe this lane is not 3.5 meters. Normally, when they put these left turn lanes, when you put, for example, I will put 1 lane, and the width of this one maybe it's 3 meters. It's not 3.5 meters. You can make that one as well. And then I will do a connector from here to here, and that's fine. Okay. Oh, I need to add a little bit curve. I added generate. For example, I will say 5, and it will create a nice curve for me. And that's fine here. Let's do this one here. And number of lanes 2. If I want to, you can see here it shows me the length of the link. I cannot change it, but I can change it with the start point. Everything here, look at the left corner here. It shows you the XY of the network here. Maybe that one helps you as well. So here, oh, I forgot to add 2 lanes. So I will change this one to 2 lanes. And I add a right turn lane here. So now my intersection is done. I draw all the links. Let's do the right turns here. So I will do a right turn from here to here. So what should I put for the spline? Any suggestions? I think 10 is fine. or I will put 15 to C. And then I will connect these ones to here. Let me draw this one to here. It's okay. And this one here to here. Okay. This one here. So now my intersection is good. No, I forgot something. I didn't add the right turn here. Why it's not? Okay. So I will say that no, first lane, and maybe 15 is good here. That's fine. And here, I will do the first. Oh, I forgot the split line. And maybe, so is it good? Oh, left turn here. So the left turns, I forgot totally. And that's good. Let's add 15 here. Okay. Let's do just its left turn, and then we will do that later. So basically, this is how you draw a network, very intersection. So as you can see, with this type of drawing, you can draw any complicated intersection. Suppose that you have a very complex seed intersection. So one lane goes up, for example, there is a roundabout on top, for example, and there is some lanes going underneath. You can draw it all with this one. And with this method, you can draw. And that's it. So now, what's the next step? So now I think we did the geometry, this part. I think we draw the lanes. We will define the terminal. We need to define the volume, the demand, the volume here, I think, first. And then we will do the vehicle composition there as well. So what was our volumes there? So I need to go and I will choose the vehicle input here, and I will add a vehicle input. I will right click and I will say that add a vehicle input here. You can see the black line here. I can double click and it will show me the list here. Or simply I can go here and I will right click here and I say that, okay, show the list. It will, if I close this one accidentally, so if I go here and I right click, it will show me the list and here. And if I don't know where this one was, I can right click on here. I say that, okay, zoom. Because we are at that location, it doesn't zoom here, but let's move it here. I will press zoom. And did I press it? It's supposed to zoom there, but it's not zooming there. But then you can go here and I will define the volume. What was our volume? 2000. Okay, this is all of our vehicle input here, 2000. That's fine. So vehicle composition, maybe, for example, I want to change it, or I can define different vehicle compositions. We will go and do default right now, and then we will go and modify it later. We had some, we need a vehicle input here. Okay, so I will say that add a vehicle input here, and then this one, how much was the value? 2500. Okay, so now let me save the network and then run the network. Let's see how that one works. So I see some issues here. What are the issues here? Sorry, what?
They disappear once they hit the end of the line.
Yes. So we didn't connect this one here. So they are just going out of the network because this is the end of their network. So we need to fix this one. We need to connect this one here, here. So I see. So that's the first issue. Let me write down. Okay. So so what else? what does it? Doesn't make sense.
No cars are going straight.
Yes, no one is going to see
Distributions.
no through movement. All of the vehicles are coming from this direction or this lane. They are just, you see here, they're all doing the left turn here, and here they do all the right. No one goes straight from here. And the same happens for this one here as well. So this is the assumption of the Vissim. Whenever they find a route, they will go it. So you need to define some routes before, so that you can define the routes. You need to define the OD matrix or something like that, or dynamic routing, or you need to define constant values there. So what else? What?
I said some of them make
Yeah,
sense.
No, I just saw one here.
Yeah.
So a few of them. Really?
Yeah.
But that's fine, but it's not right here. We will define it and we'll see how that one goes. Do you see any other issues? I don't see. Okay. So let's, first of all, the first issue. So I want to links and I want to connect this one to the left lane here. So here to the, not to the, I want to connect it to the second lane, and here 15. So now let's run it. Ask me to save changes. Oh, sorry, I just put the right. So now they are working fine. But I see one issue added. You see they are passing each other. They're going through, because these links actually they're not connected to each other. So these are like they are elevated from each other. Not elevation, but they are, as you can see, they are passing over each other, which we do not want that to happen. Yes. So we need to define the right of way and some other things. So we need to define right of way for these values. Anything else? Oh, we need to solve the military movements first. Okay. So here, as you can see in the vehicle inputs, I can define vehicle routes. Okay. So here I will say that, okay, I want to define a route. So here I need to define 3 routes. One through movement, one left turn, and one right turn. Is it right? So I will say right click, I will say that, okay, add a vehicle route. So it say that, okay, this is my first point. I want to, as you can see, I will say that, okay, my first route is from there to here, okay? My second route is to my right turn here, and my third route is to my left turn. As you can see here, let me raise this one, and I'm done. I will press the escape, and that's done. So now I have 3 vehicle inputs. As you can see, there are some markings here. Here, you can see here, the origin is defined by the red one here, and this is the cyan one here, is the destinations. I can right click here and say that, okay, object as a list, you see there are 2 objects, a static vehicle route, and there is a link there. I can raise this. I can go here and say that, okay, show the list to me. And it will show me the list. So here I have my first vehicle routes. As you can see, it has 3 options. You see here, number 1, 2, 3 here. And there is one thing important here, is their relative flow. So for the first one, which is the through movement, as you can see, when I select it, it shows me this through one. This is the right one, this is the left one. I can make it through movement for myself if I want to make it meaningful. I would say university through movement. Sorry, through movement. Oh, I'm writing in through movement. This is the right lane here, right turn, and then here left turn. So here the through movement should be 75%. This one should be, this is the right turn was, how much was? 10. And then here it's 15. Is it right? So that's fine. So let me run it and see how that one works. Now that one works fine. Now we want to define the signal timings, okay? So here, let's go to the, uh, let's go and do the uh, signal timing. So first of all, when we want to go and define the signal timing, we need to go to, there's a menu here, signal controller. So there's a concept here. So first of all, we need to define a signal controller. So this is how the Vissim signal controller works, signal system works. So there's a signal controller, or they call it SC here, and this is the part that is responsible for controlling the signal groups. So and each signal controller, so each intersection normally have one signal controller. Normally we do it for each intersection. So the signal controller normally have different phases, which here in Vissim we call it signal group. Okay, so it can have multiple phases. Sorry, phase one, phase two, whatever, how many phases you have in your system. So now we need to define a signal controller and then define the signal groups here. So the signal controllers are normally divided into different type of signal controllers. So you can have fixed time, you can have ring barrier model, or anything like that. Or even you can have an external program who controls the signal. So for example, you are going to develop your algorithm for signal optimization, you can use that one. But now for the purpose of this training, we will use a fixed time signal controller. So as you can see, there is a signal controller here, a menu. I'll go and say that, okay, I want to define a signal controller. So now I will right click here and I will press add. So as you can see, the type here is basically, it opens this page for me. So I will call it King University. Okay. So what's the type? It's fixed time, external, or ring barrier mode. So I would say that, okay, fixed time is fine for me. So you can, even for the fixed time, you can develop your own program later on, or you can just use the default Vissim controller, which I recommend using this one for the first time. And then I will go to here. I will go and try to edit the signal controllers and add some signal groups. So I will press edit signals. As you can see, this program will open. So now I had two, because it was a two-phase signal, I need to add two signal groups. I will add one signal group and then second signal group. So I will say that, okay, this is university, for example, university, and this one I call this signal group. Let me call it university signal group, and this one I will call it King signal group. I can add notes and other things. Then I can go to each of these ones and say that, okay, what's the type of the signal head there? So normally there is red, green, I don't know, red, amber, red, there's all red or something like that. So here I will choose the default one, which is red, all red, or, and then green and amber here. And this for the second one here. So here you see the default durations. So we normally do not change this one. So normally 3 seconds of amber is good, 1 second of all red is good. Sorry, all red is good, and then we will change the red and green times in the signal program. Now I will go to the signal program and I will add the signal program here. I added my signal program, and then I will go here and I will edit this one. So basically it will show me all of the phases here, as you can see, university signal, and then signal group and King signal group. I can go here and edit these values here. At the first, I can define the cycle length at the top, you can see here. And here the offset, if I have multiple signal controllers and for some different signal intersections, I want to define the signal controller. And here I want to go, the switch point is for the offset, but that's fine. We will leave these ones as is. So here I want to change this one. I will just simply grab this one, and let's say that, okay, I want to have half an hour, for example, 30 seconds for the through king signal group, 30 seconds uh, for the, what do you call it, the king and university one. So I will keep this one because there was a 3 seconds amber. I will do to 27 here, and the end one will be in 30 seconds. And then here I will do here from the 30 seconds. So now I have my signal groups, and then I will save it, and that's done. Very easy to set up. If you have multiple phases, for example, I had maybe, for example, I had dedicated left turn, and I want to have a dedicated left turn for University Avenue. So I will add a signal group here, and then I will, for example, I will just do, for example, University left turn signal group. Okay, and then I will go there, and for example, I will add here, as you can see, it's all red. I need to change it to uh, green and red. Sorry, flashing green and red. This is how the signal left turn normally works. And then here, for this one, I will go and I will change it from permanent to this one here. And then I will say that, okay, when the university starts here, I will have this one as a here, and this one I will move it to the end of this one here, like this one. So at first I will have, let me move this one up. I think I can move this one up. No. But as you can see, for example, my signal group starts with king, and then the king street will be red. Then I will have a flashing left turn for this one, and then I will have the through movements left turn. But for just sake of this simple, I will delete this one, and I will remove this one, this signal group for now. We may add it later. Let me delete it. Mm. I will just do it permanently green, just right, and then I will come back later. So now I need to save this one and then go to the intersection. So now I need to go to the left area here, as you can see. I need to go and define my signal heads. Yes, so signal heads here. So here for the through movement, I need to add a signal head. Right here, you can see it here. I will just control and click here. So you say that, okay, this is the number one. It's associated with signal controller one and the signal group one, which was the university one. Okay, and okay, so what's the one important thing here is this signal head is for which type of vehicle? It's for all of the vehicles, or car, or high vehicle, or bus. So, for example, you have a dedicated bus route, and so maybe you have a signal preemption for them, and you will give them priority before the signal timing. So you will just add one signal head for them, and then you will say that this signal head is for buses. And that's it. I will say okay. Very simple. And here I will add one other. It's for signal group one. And here for the right turn, I don't have signal red on right turns. For this direction, I will add here. It's for signal group controller one, but signal controllers, my second signal controller. And then I add one signal head again for the second one, and there is no right turn. Let me run it and see how that one works. So as you can see, I made a mistake. This one is associated with the signal controller one. I need to modify this one. Um, that's right. And I didn't do for the left turn. So I need to add one for the left turn here for the signal group second, my second signal group, and I need to go and modify this one. I did it on purpose because I want to go and edit it. And it should be for my signal group 2, which should be fine. And here for signal group 1 should be fine. Okay, now that's fine. Now amber, and then all red, and then my vehicle is started. So now I have a signal controller here, and which it works fine, but there's only one bug here. You see here the car didn't merge here. When there is red here, we didn't define the right of way. They didn't go and collapse to each other. Not collapse, but actually you can see here, you can see all these cars here. So we need to go and define the right of way. If I click here on the conflict areas, it will show me the conflict areas where the vehicles have conflicts. So go ahead. Okay. Okay. So whenever we want so the signal system of the Vissim works in this way. So you have a signal controller which controls each individual's intersection normally. So normally for each individual intersection, we normally have one signal controller which we define as fixed time, and then we will define different signal groups. So for example, this two movements of the university have one signal group, and this direction have one other signal group. So that's how it works. So that one is done now. So we need to define the right of way for here. So as you can see, there is a priority rules here. I will go and I will say that, okay, I want to add a new priority. So this one is, I want to add between this one and here, this one here. Okay. So we say that, okay, for which vehicle classes I want to do add this one here. And as you can see that, okay, I will say that this vehicle needs to stop when the signal controller 1 and the signal group 1, which was our through movement state, is green. So whenever I have vehicles coming from the through movement of the signal controller, I want these vehicles to stop. I'll say okay, and now I will run it. So as you can see, when there is no the signal control is red, they do not have any stops. But when it turns green, they should stop, as you can see. So I think this intersection seems to work nice.
But
What
still
happened?
they clap.
What happened?
They just crossed over two vehicles. The one looked like it stopped into the gap, and then the other one it just went into the vehicle.
Okay, so that's what I think
Okay. It's at the end.
Oh, at the end of that one. Yes, at the end of that one. So we need to define. So okay, we will add that one later, and I think so. I think I need to move this one to very close to here. Oh, sorry, I cannot edit it while the simulation is happening. I will move it forward here, and this one here. So I want to see they want to stop right before they want to do. So when there is a vehicle, so they do not collapse. I think this should solve the issue. Okay, so we'll fix this one later, but just let's move on with that's happening. So now we have a network which we are happy, I think, almost happy, not happy, happy, but we can just move forward with that one. We can add multiple signal groups, which is similar to this one. You can add dedicated left turns, dedicated right turns, and do whatever you want to do. So let's move on to the next part that we want to do, which is we want to have. So now we did all of these ones.
Sorry, one question I do have.
Yes.
I haven't sorry. Regarding the priority rules,
Where would you put like the first line and the second line?
So what?
Where would you put those?
These ones.
First one, yeah, first green line and the second triangular.
So whenever you want to put it, the first one that you put is the one that should stop, give the right of way to the other one. That's how we normally do it.
Yeah, well, but I was just wondering if you would put it a little bit further, or you put like
The reason
exact
that
location.
we can put it there. That's better because what we are seeing that the vehicles are going crossing each other. That was the situation which was happening.
That's why you dragged it.
Yes, so that's why. No, we should always forward. We can fix it, and that's how it's done. Yes. But I got it. So I think this the solution that we need to solve it here is that okay. We said that okay, whenever this signal is green, the signal control group 1 is green. Yes, because there is on red and there is an amber sign. So the way that I can solve it, say that okay, when the signal group 2 is red. So this one, whenever they are red, there is no green, so they will have the right of way. I think this one will solve the issue we had. They were not supposed to do that.
Well, actually, if you do like conflict
Yes,
areas, it's gonna be more
yes,
smart.
yes. So the solution, the final solution is the conflict areas. He told you can go over the manual and do with the conflict area. Okay. So here is the conflict areas, and we can define the conflict area and solve it here, and give the priority to the movements. But just you can do it later. So let's move on to, because we are out of time and we need to do the rest. Okay. So here now we have an idea about how we can draw the network, how define the signal controls, and how define the links, volumes, and you can basically run a very simple things. Now I want to go to the evaluation part. So because the most important part when you do the simulation, you want to extract the information. What you want normally, what we are interested in is that we're not interested in travel times. We are interested in delays. We are interested in the number of queue. So these are the information that we are interested and we want to do. So here I move here. I will go to the data collection part here, as you can see here. So I want to add, for example, travel time. I want to monitor the travel time over this segment of this intersection. Okay. Um, so I want to add some information here. So I will go say, okay, I want to do add travel time monitoring system. So I will put it here. I will add vehicle measurement here. I will put my first point there, and then I will put. Oh, sorry, I pressed it double. So I will add one here, and the second one here. So I want to monitor the travel time between these two intersections. Basically, I want to monitor the dwell time around the intersection. Or maybe you have multiple intersections and you want to see how is the progress of the vehicles there and how is the delays and how you can improve your signal timing. So as you can see, there's a name, where is the location, first location, last location, and then I will say okay. So one of the menus here in the Vissim is the evaluation menu, which is very important for us, which we will say that configuration. So it says that, okay, what type of evaluation I want from Vissim and how they are going to export it. First of all, as you can see, there are two type of evaluation. Normally, the result attributes, which is some sort of summary and these information that we put here, vehicle inputs normally, so vehicle travel times and other things, and there's direct output, which is good for directly outputting from the Vissim. For example, you want to trajectory of vehicles, and you want to go and draw the trajectory of vehicles. You need to go to here. So first, let's go and do the travel time. So we were interested in travel time. Yes, we say that, okay, collect this data for me. So and start from zero. When do you want to start from simulation? Because normally what we do in simulation is that we give a warm-up time. So we say that, okay, forget about the first 200 seconds because the vehicles are not distributed in the network. The network is empty. Normally we say that, okay, let's forget about the first 5 minutes, and then when the volumes in all of the intersections reach to the my expectation, do it. But now for this purpose, for this simulation, we will just put 0. And then we will say that, okay, 2 times. What's the end of the time that you want to monitor that one, which is normally almost end of our simulation. And I can click more and say that, okay, there are some other additional options normally associated with each of these ones. I say, okay. And now when I run the simulation, in my working directory, which I can open it here, where I save the file. As you can see, there is a folder which our file name was link, and the link results. Sorry, let's wait until it generated some vehicles. Oh, sorry. We were in the. Okay, we did it here. Okay, so the summary. The summary one will appear here. Evaluation, Windows, and then I will say that. Sorry. Result list, and then I would say that vehicle travel times. As you can see, it's now collecting the vehicle travel time for our intersection here. And then I can copy paste this information here. But as you can see, the time interval for this one is very huge. So it's from almost from the beginning of my simulation to the end of my simulation. So what I will do is that I will go to my evaluation and my configuration and say that, okay, my interval is that I want it for each 5 minute interval. I would say 300 seconds there. I say, okay. It says that, okay, whatever you collected before, it will be deleted. And say, okay. Now, when I run the uh, simulation, as you can see, it will create for all of my time interval here. And you see this is the number simulation run, which is my 11th simulation run. What's the measurement area, which was 1 here, as you can, we defined it. And then it will tell me what's the travel time. We need to wait for at least 350 seconds here on my simulation here to go on. It's now 40 seconds. I can go here and click here on quick mode, which disable the UI, and the simulation will do very fast. As you can see, the speed increased a lot because it's not going to update the interface for me. Here is the, oh, sorry, here is the simulation seconds. As you can see, it doesn't update here. If I remove this one, now you will see the vehicles and the values are being updated. But let's do it for the rest of the simulation, and I will export this one. So I can say directly save this one to file, and it will ask me, okay, where do I want to save? Let me stop the simulation, and I can save it to a file and say that's it. Okay, link travel time results, for example, test 1. And then whenever I go to here, you see this one is a text file. Normally they do it this one. You can open it with Notepad. As you can see, all of the outputs of the Vissim is like this one. Say that, okay, this is the file, and this is the vehicle travel time results. What are the columns here? It's simulation run, time interval, okay. Vehicle travel time here. You see that is my 11th simulation run is from interval 0 to 300, and then number of vehicles, for example, in that, sorry, the vehicle inputs in the data collection point, which was 1, and number of vehicles which entered the network there, and what was the average travel time there, I think. Yes, average. This is the travel time, the total is average travel time, I think. And then so I can use this information for my analysis. For example, maybe in your assignment, one of the questions is that, okay, so draw the travel time for this segment of the road over the simulation period. So then you will just extract this information, you will define the travel time study area, and then you will collect those information from that one. Or you want to draw a greenfield model, and you want to extract the volume density feature. So now you have the volume, the number of vehicles which pass that section. you have the travel time, and then you can go and draw what you want from there. What you can think of. If you have any trouble doing, yes.
As I wasn't clear, can you please quickly just repeat how you record the travel time on a
Sorry, I think we're out of time. After the class, come here and I will tell you that one. But I will do some other processes which is similar to this one, and then you can learn on that one as well. So basically, normally what I do is that whenever I want to import it, I import it to Excel. I normally remove this part normally, and then I go and I will go to Excel. Just very quick information, and then I'll click a blank, and then I will go to the data and say that okay, I want to. What was the external data? Okay, external data. I say that okay, I want from a text file, and I will go and browse for uh, sorry, all the files. What was the file here? And so I will say that okay, this delimited file, and say that okay, that's it, and it's delimited by semicolon, and then I will have it. Then I can draw, for example, the travel time over the time interval very easily. Just that's how we normally do it. Or you can export it to the Access. I think it has a feature to export it to the Access as well here. Export it to the database. But sometimes it's tricky because if your version of the Office is not, for example, this one is a 64-bit. If your version of Office needs to be in 64-bit, otherwise you will have trouble. But forget about that one. The text file works very fine for you. So now let's go and do, for example, queue counter. I want to monitor the queue because I want to monitor, for example, I want to see how is the performance of my signal controller and how that one works. So I can put a the queue counter here at this link, and then I will go to my evaluation, to configuration, and then say, okay, extract the queue counter for me, and then do it by 300 seconds. Okay, and I can define some criteria here. For example, whenever the speed of the vehicle is less than 5 kilometers per hour, it will assume it's in queue. There are some parameters here. Go and look, check the manual, and you will get the more information there. And then the rest is similar. I can just run the simulation, and I can go to the evaluation and to the window. Sorry, result list. Sorry, result list, and I can say that okay, queue length, and it will show me the queue length as well. I can ask the software to do the average for me. You see, if I click on this one, it will add the average on at the end. So you see queue length max and other queue stops and other values are calculated. So if you don't know what's the meaning of all of these ones, go to the manual. It will have very detailed value of these ones. So now we are done about the average ones. Let's go to the second tab. You can see all of this information, delays. So for example, maybe the delays are important for you. You want the vehicle, so you want to export of the delays there. You can do that one. You can restrict it for different vehicle types and different values. Let's go to the direct output, and it's a good option here. So for example, one of the most important things here is that vehicle record. So I want the Vissim to export the trajectory of vehicles. So for example, one of your questions maybe in your assignment is that select one of the random vehicles and draw the trajectory of the vehicle and calculate the stop delay. I think last week you had the stop delay, you have calculated the stop delay. So you want to go and draw the trajectory of vehicle, for example, something like this, and then calculate the delay. So what we do is that you normally go to the vehicle record and say that, okay, export the vehicle record for me. I will go to more and I will say that, okay, what attributes I want to be exported, okay? So normally say that simulation second, vehicle number, the lane it was there, and the position. So I want, for example, the speed of vehicle to be exported as for me as well. So we say that, okay, speed, I want the speed there. I want the acceleration. Where is the acceleration? Here. acceleration. I want the delay, so delay time. So at each time interval, it will export me the delay of the vehicle, or desired speed. So what's the desired speed of the vehicle? Because the desired speed of each vehicle is generated randomly for each vehicle. So whatever information you want from here, you can extract it here. I will say okay, and then I will say okay, and as you can see, it will export to the direct output directory is, I will just change it to, that's good, Vissim sample, that's fine. Let's do export there. And I will export the travel time of the vehicles there as well. Okay, and as you can see, so there are two options: write to file, write to database. I normally do the write to file. I will say okay, and then I will run my simulation. So let's finish it just right now and go to the output directory. Okay, as you can see, now I have two files. The fzp file is the trajectory file. I can open it with Notepad. I normally use Notepad++. I suggest you to use Notepad++. It's free software and it's very good for editing text and other things. And so it's the similar one. So it says that, okay, all of the information I asked for the software to export to me is here: simulation second, speed, acceleration, and I can export it to import it to Excel as we talked in previous one. So now I have the trajectory of all these vehicles. For example, this vehicle one, as you can see, this is the location X and Y, and I can export all of this information. So, and then I have this RSR file, which is the vehicle travel time information. As you can see that, okay, this vehicle and at this travel time the travel time monitoring section that we added late first between two sections, this vehicle the vehicle type and then the travel time here and what's the delay for that vehicle. This is very good for your studies. So you want to see that, okay, in this section of the roads with my decision, how much is the delay for each individual vehicle? You will have it here. Go through the output of the Vissim and you will find a lot of useful information here. Normally these are the typical ones that you will use, but it will give you a lot of things. It can draw charts for you, do a lot of things for you. And then that's done for the evaluation. Let's go to the simulation.
Where's the output of this thing?
Sorry, what?
The output of
Direct output, you go to evaluation, configuration. There were two tabs. So one was the result attribute, which are the results that we were seeing in these charts here, and we say that collect these on Q counters and other things. There is one other one, which is the direct output, which gives you the direct measurements of Vissim. So for example, Vissim took this information to calculate, so what was here? Vissim took this information to calculate one of these outputs in the result one. These are the direct output, the detailed one of the Vissim. Then that's it. So let's go to the simulation one. So if you go, I go to simulation parameters. As you can see, there are multiple parameters here. The first one is the period. So how much is the duration of my simulation? So here's 3,600, 1 hour. If I want to simulate my network for 7,200 seconds, I will put it there. So what's the start time? Because if you have some variation, because for signal timings, you say that, okay, my signal timing start from 10 o'clock to, for example, 2 o'clock. This is my signal timing. You will define your start of simulation, and that one changes some variable there. But you normally do not change this one. And the date as well. The simulation resolution is that, so as I told you, so it's a continuous, Vissim is a continuous simulation system. So it will move the simulation sequence step by step, and then it will monitor all of the vehicles and change the situation in the network. So say that, okay, so here says that my simulation resolution is 10 simulation seconds per, 10 step per simulation seconds. It means that each time step is 1/10 of a second. Okay, so this is the accuracy of your one. So this one, if you increase this one, it will reduce your performance, and you will have a lot of time steps. So simulation will go 1/10 of a second, and then monitor all of the vehicles, and then move them individually. If we put it for two, for example, 5, it will be faster. If we put it 1, it will be very fast, very fast. But it depends the accuracy that we want. For example, when you are modeling a highway, normally the vehicle speeds are very high and you don't want that much accuracy. But whenever, so you can put maybe 2 or 3 or 5 something. But whenever you're modeling an intersection and in urban area and you want to have very accurate model and you want to do estimate the delay accurately, so you will put it higher here, this value. So it depends on that one. Normally 5 is a very good value. Normally I put it 5 to 0.2 seconds. The random seed is the value of so whenever we want to do a simulation, we need to generate some random variables. So they are not actually random. They call it pseudo-random numbers, which they come normally some relationships and some values that they will try to generate some random numbers. But we are doing simulation and we want to regenerate the results that we have. So if we put a value here, so then we can, if we were on the simulation again and again, we can get, with the same configuration, we can get the same results. But if we want to see the difference, because the value, the evaluation that we are doing is dependent on the time of arrival of the cars and some other things. If we want to do multiple simulation, we normally do multiple random states and see and then average and get the results and do some averaging on those ones. As you can see, so Vissim can do that one for you. As you can see that you can say that, okay, for my simulation, I want Vissim to do 5 simulation for me. So that it will run your simulation 5 times and it will each time it will increment the random seed. And then it can do the averaging for you and some other calculation for you. So that's these two values here. And the simulation speed is that, for example, sometimes you want to capture your simulation and you want to see, okay, so there are some, and show it to someone. You want to have a very good screenshot. You want to put in, for example, 1 second per, 1 simulation second per second. But normally it's faster. Normally our processors are normally faster and they can simulate maybe 5 seconds per one, 5 simulation seconds per 1 hour seconds, real-time seconds. So this is normally I put it maximum to get the maximum performance. And then you can specify a number of, okay, the great hat is that you can say that, okay, my solution is for this long period of time, but for this study, I want to break that, for example, 2,000 seconds. So you will specify there. And then the number of courses that, how many courses should it involve in doing, it can do some sort of multi-core processing. So, and so it will use that one. So now we are almost familiar with evaluation, simulation, signal control. Let's go and do a quick review on the base data and the traffic. So the base data, the function of base data is that we want to define some of the characteristics of the simulation. Because each simulation is normally calibrated for different situations in different environmental and there are very behaviors. So for example, suppose that your vehicle types, their acceleration and deceleration rates, maybe they are different than the normal behavior. So different location on the board, I mean the planet, they have different type of vehicles, different behavior. So you want to go and modify these values. So you can go there and you can define, for example, functions for maximum acceleration, for functions for desired speed. For example, I will go here and you can see here, there are different values there. You can go for distributions. Okay, what's the distribution of desired speed? So you have different desired speed and what's the distribution, lower bound, upper bound, and you can even define the custom ones. I'm not going to the details because we don't have time for the details here, but I'm giving you the idea of where you should go and look for it, and you can go for the manual and check that, the manual for that one. You can go, for example, go to, where was it here? Okay, so vehicle classes, vehicle type, driving behaviors. Okay, so here's you see that urban, motorized, and freeway one, and I can go and edit. Oh, sorry, I press delete. Okay, so I can go and edit this one. As you can see, it says that, okay, how's my car falling model? So I can say that Whitman 74, Whitman 99, or no other ones. So what's the look ahead distance? What are the lane change rules? These are default values, which Vissim says that these are default and they are good values. But if you have a study and you want to change these values based on your model, based on your studies, and based on your data collection. For example, I have one friend, one of the PhD students, Professor Helga, he's working on seeing the effect of the weather on travel time and travel time reliability. Rizal Wilson is doing that one. And he go and modify these values. So say that, okay, when we have winter, maybe the maximum deceleration is changed. So basically in the winter, they have maybe lower maximum deceleration, or they have accelerated deceleration. There are different values. So he tried to modify and calibrate the network for those values. These are the things that you know, and you need to go and change it based on your needs. And sorry, where was base data? You can, one of the main features of the Vissim is the pedestrian simulation. So for some of the CBD's areas, the only, I mean, the influence of the pedestrians are significant. So there are a huge amount of pedestrians who are moving, so you need to simulate them. You can simulate them very beautifully, and it's a very nice feature of the Vissim, and you can define those ones. And that's it. One other feature of here is the time intervals, which is important for you. So here it says that, okay, you have one time interval. Suppose that you, in your network, you want to simulate the volumes for multiple time intervals with different values of the time, different values for the volume. So for example, I will come here and I will add different ones. So for example, from 0 to 1,800 for half an hour. Oh, sorry, I should edit it from here. For the first half an hour, my volume is, for example, um, instead of 2,000, it's 1,500. So then I can go here to my vehicle input. I will say that, okay, I want to, okay, showing list. Okay, here. So as you can see, I can say that, okay, single links, I want to say that, here you see there's a view option. I will say that, okay, show me vehicle input by for time intervals. I say that, okay, this one is 2000 for the whole time interval. But here I'm not satisfied. I want to add something. Okay, I need to, where is my, did I save it? The time interval here. Okay, this one is done. And then let's go to my vehicle input. And I want to, okay, I need edit time intervals, okay, for that one. And I can edit that one here. I don't know why it doesn't recognize my time intervals. It's opened a new interval, but that's fine. Then I can go to the driving behavior. Sorry, where was I? Vehicle inputs. And then so I can say that for first 15 minutes, my vehicle input is 2,200 vehicle per hour. And then that's my second one. And so the volume can varies in my different time of simulation. And then with base data. In the traffic, sorry.
22,000?
Sorry, that's a mistake. Sorry, that's a huge. It's a net. I mean, it's a network block, but that's fine. And in the traffic menu, I can define some of the behaviors of the uh, traffic. Vehicle composition, as we talk. So we have the default vehicle composition. As you can see, it's a combination of the cars and high HGVs. So I can the trucks basically. I can define different type of, for example, my vehicle composition, and I can say that, okay, I have maybe 80% vehicles, and I have, um, for example, bus, maybe 5% bus, and then I have high vehicle link as the value is, for example, 15. Don't worry about these values to add up to 100. It's a relative. If I put here 10, it will take 10 over 80. What's the total values? What's the 95? So it's a relative form, but don't worry to add up 10. But I normally like you to do it this way. And then, for example, in my vehicle input, uh, I can go to the show to the list, and then I can change the vehicle input to my VC and change that one for my vehicle input. So there are various options. I think now you have the idea about what's going on in Vissim, what's the main features, and where you can find the information there. So then you can go forward and do the simulations.